All right, so this is actually going to finish out our notes for Unit 4, but it's the first time I'm giving you the notes as a podcast, so hopefully it's pretty quick and simple. We're just covering page 13, how to name acids. And at the top, it tells you a few pieces of information about acids, and we're going to study them a lot more in depth later on. So know that these are a specific type of molecule that act a certain way when put in water, and they are going to technically look covalent because they're going to start with an H, which is a non-metal, so it looks like a covalent compound, but they're kind of a special type of covalent compound that are super polar. They're right on that edge between covalent and ionic. Remember, it's not just black and white. There's some gray area in between. So these are actually going to act more like ionic compounds. You see they produce these charged H pluses in water, and they dissociate just like our ionic compounds do. So because they have these charges, we're going to find the symbols and charges for the two pieces of our acid and cross-drop reduce them just like we did for ionic. It's just that they look a little more like covalent. So it's kind of right in between those two. But let's go ahead and jump in. There are 3 different types of acids, and there's different rules for writing their names for each type. And we kind of have to understand the rules of how to write the names to understand what pieces, what ions are going to be in the formula. So this is mostly focusing on the names, but it's also going to help us find what we need for the formula so that we can do that cross-drop reduce. So our first type of acid is a binary acid, meaning 2 elements, and H is always going to be that first element because it is an acid. So there's just one other element with this H. These are the shortest, simplest formulas, but they have a slightly longer name. The other general type of acid that we have is going to be an acid that has a polyatomic with the H. Those are those elements and groups of elements, rather, from the back of the periodic table that we learned about. All of these polyatomic ions can get with a hydrogen and make an acid. So if we see a polyatomic with an H, then it's going to be one of these second or third types of acids. And like I was saying, with our shortest, simplest acids, the ones that are just H and one other element, the name is actually quite a bit, well, just a bit longer than these other types of acids because we're going to use hydro at the beginning of the name. And the way I remember that is to use hydro in our acid's name only if the formula has no oxygen in it. So you can remember hydro when there's no O. Because remember, these polyatomics that we have that might go with our hydrogen here in these last 2 types of acids tend to be a group of an element with some oxygens with it. So hydro is used at the beginning of our formula with those binary acids when there's no O's. Then the end of that element's name is going to change, just like with ionic and covalent, but instead of changing to "ide," it's going to change to "ic." And then, of course, because it's an acid, we add the word acid to the end. So hydro at the beginning, and then "ic" at the end, followed by the word acid. With our polyatomic groups, instead of that "ic" ending, we're going to have to judge how to end our acid's name based on how the polyatomic name ended. So here, when we have our "ite" version of our polyatomic, the acid's name is going to get changed to end with "us." You basically take the "ite" off, replace it with "us." If we have the "ate" version of a polyatomic, then that name is going to change to have that same "ic" ending that we did with our binary acids, but remember, there's not going to be any hydro at the beginning. So hydro at the beginning if it's binary, then "ic" at the end. If it's not a hydro acid, if it's a polyatomic acid, there's no hydro. We just have to focus on changing the ending to be either "ic" or "us," depending on the polyatomic's original name. And I have a kind of silly saying, kind of as usual, that helps me remember how to change these endings. It's "ic, I ate a humongous bite." Random, I know, but this just kind of helps you connect the "ic" with "ate" and "us" with "ite," so that you remember which way to change our acid's name depending on the polyatomic's name. Now, this might kind of seem complicated and detailed, and we have a lot of examples filled in here so you can see this happening, but I kind of wanted to give you just a simple summary depending on these types of acids. So binary, remember, just two elements. It's going to be hydro something that's related to that element that's with the hydrogen, ic acid. Then our two polyatomics, depending on whether it ends in ate or ite, is going to end in ic acid or us acid. But notice there's no hydro there. So that is our general format for our three types of acid names. And I think it's probably time to do some examples so that this will make a little more sense to you. I already have that red line show up, and I have a couple other things that I want to pop up here before we start working out these problems, because I do want you to make these changes to your paper so that we can get a little bit different types of practice going on here. So just cross out that little thing at the first column of row 3 there, so that we're just looking at one ion. There was a typo there in that second bit. Change chloric acid to chlorous acid and hydrobromic to hydronitric acid. And then we'll fill the rest of this in together. So let's start with just how to write a formula if I know I have an acid that is an I minus ion with it. Remember, all we're going to do when we write formulas is cross drop reduce. So kind of just imagine an H plus there in front with that I negative 1. A plus 1 and a minus 1 are just going to cancel each other out, which means that our formula is going to be HI. Now, that is iodide. It's just a simple single atom, not a polyatomic. So our acid's name is going to need to start with hydro because there's no O's in that formula. And then that's going to end with ic acid. So hydroiodic acid. Took that word iodine, and just instead of changing it to iodide, we changed it to iodic acid. So that's if I told you make an acid with this I minus molecule. And that's not going to happen very often. More often, I'm going to give you an acid's formula and ask you for its name, like what we see in row 2. But you still have to kind of take a pit stop by thinking, what is this piece? What is this ion that's with our H's? And once you know the name of that piece, then you can name the acid. So if we focus on the thing that's with the H, kind of ignore the H's, that's PO4, would have a -3 charge according to the back of the periodic table where I found it. And also what I find back there is that the name of this thing is phosphate. And if that's phosphate, it's an 8 polyatomic, then I'm going to basically change that 8 into ic, because ic goes with 8, and that's going to become phosphic, or really phosphoric acid. I just add an extra syllable there because it made it sound better, I think. It's still kind of that root word phosphorus. We're just changing that to ic acid from our phosphate. Now this next one is kind of a crazy looking ion. That is our acetate ion. And I know it doesn't show that -1 there, but it is a -1. That's the only thing we could have if I had a negative charge there. And so if we start by writing the formula, imagine putting an H plus 1 with that acetate ion. It's a +1 -1 again, so we don't need to add any numbers. We just need to shove an H along with that acetate ion to get our formula. And then once again, like our phosphate, it ends in 8, so we're going to change that to ic and add the word acid at the end. So this is acetic acid. This next example, HNO3, is going to go a lot like the first row. I have a formula. I want a name. Let's figure out what the name of that thing with the hydrogen is, and that is NO3, which we call nitrate. So once again, ends in 8, change that to ic, we get nitric acid. So let's write a formula here that's going to need us to cross-drop reduce. This next piece, SO4 minus 2, if I'm wanting to put that into a formula, I'm going to put it with an H plus 1. H's are always at the beginning of our acid formulas. And here, this -2 charge is going to have to cross over onto the H. H's plus 1 is always going to be what's crossing over onto that ion, and we never write ones, so the only number our acid will ever have in it is going to be a number on the H that's going to represent what the charge of that ion was. So this is going to become H2SO4, that 2 from the sulfate crossing over onto the H, and it's done. And because this is sulfate, much like all these other 8 ions that we've been working with, this is going to become sulfuric acid or sulfic acid. Totally gets full points. Not a problem there. It's, there's a couple of times that chemists just add an extra syllable here. So now let's work backwards from a name to the formula. But once again, we're going to take a pit stop by asking ourselves, what is that anion? What is that thing that has to be in our acid to write our formula for, based on what we're seeing in this name? So because this next one is chlorous acid, we know us comes from ite. So that must have been chlorite that's with this acid. And if we look at the back of our periodic table, chlorite is ClO2 with a -1 charge. And if I cross-drop reduce that with an H, it's just HClO2. This next one is hydronitric acid. And hydro means there's no O's. So I'm not going to look at that polyatomic list on the back of my periodic table. This is just a normal element, a single atom from the front of our periodic table. And if that's nitric acid, then that's going to be nitrogen, or the nitride ion, which is just N with a -3 charge, and always has a -3 charge. So if I cross-drop reduce that with my H plus 1, we get H3N. Trying to find another name here, H2CR207. We start by figuring out what is that CR207 thing that on the back of the periodic table tells us is dichromate. And so 8 changes to ic, this becomes dichromic acid. So that's where I'm going to stop. I want you to try to finish out these for your stamp. Even if it's not perfect, I will stamp it as long as you've given these last few problems a try. But if you're uncertain about whether your answers are, or if they're correct or not, please feel free to check them with me in my packet at the front of the room when you get to class. But I do want to see you try those out. Shouldn't be too bad. And we're going to be reviewing and quizzing next class together. So you need to give these a try. See if you can get them done. These aren't going to be our priority. There's going to be a lot more ionic and covalent on that quiz, but you will see 1 or 2 acids. So I want you to see if you can get these types of names and formulas figured out.